Hello great aspirants, welcome to CSIR NET Classical Mechanics series. Question number 1. A sphere of radius r is held fixed on a horizontal ground. A point particle of mass m slides without friction from the top under the action of Earth's gravity as shown in the figure. The speed of the particle when it leaves the surface of the sphere is. Let's assume that it will leave at some angle theta. So at that point we will apply energy conservation. So initially particle is at rest, so its initial energy is potential energy, and we will assume that this is the reference point at which potential energy is 0. So initial potential energy will be mgh, here h is r, and that will be equal to final potential energy plus kinetic energy. Now let us assume this is the height h and it can be written as r cos theta. So this will be equal to mg r cos theta and plus its kinetic energy, that is half mv square. We can cancel m throughout, and from here we can write v square is equal to 2gr in bracket 1 minus cos theta. So that will be the velocity at that point. Now the centripetal force required for this movement, it is provided by its weight. So let us assume that its weight is acting mg downwards, and one component, that is mg cos theta, it is providing the necessary centripetal force. So mv square by r is equal to mg cos theta. Plus some normal reaction will be there, but the moment it loses contact, that normal reaction will be 0, so we will not consider it. So from here v square is equal to, here let me write r, so v square is equal to gr cos theta. Now we will equate equation number 1 and equation number 2. So this will be 2gr minus 2gr cos theta, that is equal to gr cos theta. So 2gr is equal to 3gr cos theta, and from here we'll get cos theta is equal to 2 by 3. So the speed, which is v square, it's equal to gr cos theta. So we'll get v is equal to under root gr, and cos theta is 2 by 3. So here option 1 is correct. Next question. A particle of mass m is subjected to a potential v of x is equal to v naught phi of x minus kx, where v naught and k are the positive constants and v naught is much larger than energy of the particle. The function phi of x is equal to 1 when x is greater than or equal to 0 and equals 0 otherwise. The particle starts from rest at t is equal to 0 and x is equal to minus 5. In the limit v naught tends to infinity, the graph for x dot is best represented by. So first of all, v of x, let's consider x is less than 0 because it is starting at point x is equal to minus 5. So at that point, v of x will be, this phi of x is 0, so it will be 0 minus kx, so minus kx. And at that point, force is minus of dv by dx, which is equal to minus of minus kx, that is kx. Okay, so it is a constant force, and we have m a, that is m dx dot by dt is equal to k. So from here we can write x dot is equal to k by m t. So this is the expression for x dot, that is velocity. Plus c also will be there. But we know that at t is equal to 0, it is starting from rest. That means at t equal to 0, x dot is 0. That means c will also be 0, and we are left with x dot is equal to k by m into t. Now if we plot x dot versus t, it will always have positive slope. That means option 1 and option 3 are wrong. Now from here we can write x is equal to k by m t square plus some constant. Now we know x is equal to minus 5 at t is equal to 0, which means c is equal to minus 5. So x is k by m t square minus 5. So we have expressions for x and x dot. Now particle starts at x is equal to minus 5 at t is equal to 0 with a constant force k, and it is pushing it towards right. Then at x is equal to 0, the particle is hitting a wall and it reflects elastically. That means velocity will reverse its direction. Now the particle moves to left, but the force is acting in the right direction. So it will just fluctuate between these values. So it will go to positive side, then at its maximum it will reverse its sign, so it will become negative and it will continue. So here option 2 is correct. Next question. The Hamiltonian of a system is given by h is equal to minus p square plus v square raised to half, where x and p are the generalized coordinate and momentum respectively, and v of x is greater than or equal to 0. The corresponding Lagrangian is. Now Hamiltonian is given, so we will first calculate x dot and then we'll use the conversion. So we have x dot is equal to dou h by dou p. Let's differentiate it. We have h is equal to minus of root p square plus v square. So this will be equal to minus 1 upon 2 root 2. So 2 p square plus v square, and derivative of p square is 2p. So this is minus p upon under root p square plus v square. From here we can write what is p. So let's take square on both sides. That means x dot square is equal to p square upon p square plus v square. That gives us x dot square p square plus x dot square v square is equal to p square, and x dot square v square is equal to 1 minus x dot square p square. So from here we can write p is equal to plus or minus x dot v upon under root 1 minus x dot square. This is the expression for p. Now it will be positive or negative. Now see this equation. If x dot is positive, then on the right hand side we have p. That means if x dot is positive, that means p has to be negative. If x dot is positive, that means p is negative. And if x dot is negative, that means p is positive. Because on the right hand side, p has to be negative, so that x dot will be positive. So to consider that, we'll consider here minus sign. So we have minus x dot v upon under root 1 minus x dot square. So that will be p. Now L is p x dot minus h. P is minus x dot into x dot square by v upon under root 1 minus x dot square minus h. So it will become plus here, and we have p square, that is x dot square v square upon 1 minus x dot square plus v square. So this will cancel, x dot square v square will cancel here, and we'll have minus x dot square v upon under root 1 minus x dot square plus, here only v square will survive and its square root will be v upon under root 1 minus x dot square. Again we can take v common, it will be 1 minus x dot square upon the root of 1 minus x dot square. So this is v into 1 minus x dot square. So here option 3 is correct. Next question. Consider the earth to be free rigid body symmetric about its north-south z-axis. If the principal moments of inertia satisfy Iz is equal to 1.003 Ix, then its angular velocity would precess about the z-axis with a period of nearly. We will use Euler's equation. We have Ix omega x dot is equal to Iy minus Iz omega y omega z. Then we have Iy omega y dot is equal to Iz minus Ix omega z omega x. iz omega z dot is ix minus iy omega y omega x omega y. Now it is a symmetric body. That means we have ix is equal to iy. Now if we check the third equation, if ix is equal to iy, that means omega z dot is 0, which means omega z is constant. Now let's look at the first two equations. From the first equation, we can write omega x dot is equal to, now I can write ix is equal to iy here. So we have ix minus iz upon ix into we have omega y omega z. Similarly, omega y dot is equal to iz minus ix upon ix, because iy is ix, into we have omega z omega x. We want to find out precision frequency. So we'll take double derivative of this equation number 1 and use equation number 2 in it. See, if we take derivative of omega x dot, then we have here two terms, omega y and omega z. Here we will use omega y dot and we'll substitute here, and omega z dot is anyway 0. So we have omega x double dot is equal to ix minus iz upon ix, and we have omega y dot omega z plus omega z dot omega y, but this is anyway 0. This is equal to ix minus iz upon ix into iz minus ix upon ix, into we have omega z omega x. So omega z square will be there. This can be further simplified. So this will be equal to minus of iz minus ix upon ix whole square into omega z square into omega x, and here we have omega x double dot. So omega x double dot plus omega square omega x, and that is equal to 0. Now this is the equation of simple harmonic motion. So angular frequency of precession is equal to this. It will be equal to mod of iz minus ix upon ix into we have omega z. Now this will be equal to, we have iz is equal to 1.003 minus ix 1.003 into ix minus ix upon ix whole thing into omega z. So this is equal to 0.003 into omega z. Now time period will be 2 pi by 0.3, and omega z will be 2 pi into time period. Time period for one rotation is 1 day. So this is equal to, t is equal to 1 day upon this, that is 333 days. So option B, option 2 is correct, 333 days. Next question. For a free particle of mass m, consider the following time dependent quantity in phase space. Q is given, where Q and P are the canonically conjugate position and moment of coordinates respectively. Then dq by dt is given by. Now if we consider a free particle, Hamiltonian is equal to p square by twice m. So q dot is equal to dou h by dou p, that is equal to p by m, and p dot is minus dou h by dou q, which is 0. Now dq by dt is equal to q, then p dot by m plus q dot p by m minus 2p p dot t by m square minus p square by m square. Now P dot is 0, then Q dot is P by M. So this is P square by M square. P dot is 0 minus P square by M square. So this is equal to 0. So option 1 is correct. Next question. A massless rod of length L is hinged at the extreme end of vertical spring whose other end is fixed to the ground. A point mass M is fixed at end of the rod as shown in the figure. Assume harmonic motion of the spring given by H is equal to H naught in bracket 2 plus cos omega t, where H naught is greater than L. The equation of motion of mass confined to the plane of figure is given by. Let's consider its x coordinate. X will be L sine theta. Y coordinate is this H plus L cos theta. So x dot will be L cos theta theta dot, and y dot will be H dot minus L sine theta theta dot. Now Lagrangian is T minus V. So L, then we have half M, then x dot square plus y dot square minus mgy. So L is equal to half M x dot square, that is L square cos square theta theta dot square plus y dot square, which is H dot square plus L square sine square theta theta dot square minus 2H dot L sine theta theta dot minus mg. We have H plus L cos theta. This is L. Here we have sine square theta plus cos square theta. That means L is equal to half M L square theta dot square plus H dot square minus 2H dot L sine theta theta dot minus mg H plus L cos theta. This is the complete Lagrangian. We will write now equation of motion. First let's calculate dou L by dou theta dot. Let me write L here. We have L is equal to half M, then L square theta dot square plus H dot square minus 2H dot L sine theta theta dot minus mg H plus L cos theta. This is the complete Lagrangian. So dou L by dou theta is equal to M L square theta dot minus M H dot, then we have L sine theta. Then dou L by dou theta is equal to this half M will cancel, and we have minus M H dot L cos theta theta dot plus, here we have cos theta, its derivative is minus sin theta, so this minus sign will cancel, mgl sin theta. So d by dt of dou L by dou theta dot minus dou L by dou theta. We can take m common, and we have L square theta double dot minus H double dot L sin theta minus H dot L cos theta theta dot, and minus this, so plus m is taken common, plus H dot L cos theta theta dot minus mgl sin theta. So this term will cancel, and we have H dot here. Now H is equal to H naught in bracket 2 plus cos omega t. So H double dot will be derivative of this, so that is H naught cos sin cos, so cos omega t with minus sign, and we will also have minus omega square. And this should be equal to 0. So m will cancel throughout, and we can cancel L also. So we have L square. Let's cancel L as well. So m and L. So L theta double dot minus h double dot sine theta minus mgl, m and L cancelled. So g sine theta, that is equal to 0. So L theta dot minus h dot is this. So plus omega square h naught cos omega t sine theta minus g sine theta is equal to 0. So here option 2 is correct, plus minus. Next question. In its rest frame, a source emits light in a conical beam of width minus 45 degree to 45 degree. A observer is moving towards the source with speed v. For the observer, the beam width appears to be minus 30 degree, 30 degree. The speed of the observer is closest to. Now we have ux is equal to, it will be cos component, so c cos theta. Uy is c sin theta. Similarly, ux dash will be c cos theta dash, and uy dash will be c sin theta dash. Now ux dash is equal to ux minus v, 1 minus v ux by c square. So we can substitute it here. We have c into cos theta dash is equal to c into cos theta minus v upon 1 minus v c cos theta upon c square. So we can divide by c throughout and then substitute values of cos theta and cos theta dash. So cos theta dash is equal to cos theta minus v by c upon 1 minus v by c cos theta. We have to solve this for v. So cos theta dash minus v by c cos theta dash, cos theta is cos theta minus v by c. So v by c is equal to cos theta dash minus cos theta dash cos theta minus 1. Now theta dash is 30. So cos 30 is root 3 by 2. Cos theta is cos 45, which is 1 by root 2. Root 3 by 2, 1 by root 2 minus 1. This comes out to be minus 0.4099, which is roughly minus 0.41. It is negative because observer is moving towards it. So here answer is option 4, 0.41c. So these were all the questions from classical mechanics part from CSIR NET paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.